17D. This deals with the shortcut for the SD. So number 1, 7, 7, -2, -2. How would we figure out the shortcut for the SD? It's always big minus small. Or wait. Oh, I see. So for letter A, we would do 7 minus -2 times the square root of 3 out of 5 times 2 out of 5. So is A correct? No. It's supposed to be 9, not 5. All right. Is B correct? Yes. Is C correct? It would be 1 minus 0, which is 1, and then 2/3 and 1/3, so yes. It didn't put a 1 in front, but you don't need it. And then D. Why won't D work? There are 3 different numbers, and the shortcut only works for 2 numbers. 2. Suppose a gambler bets $1 on a single number at Keno. Keno is kind of like a bingo game. In 100 plays, the gambler's net gain will be blank, give or take, blank or so. So 289. We play Keno. And what's the chance of winning? There's a 1 in 4 chance of winning. Okay. So, what's in the box? When we play Keno, what's in the box? There are 4 zeros. And then you get the $1 back and $2 more. And then there is 1, 2. Oh, I guess. Yeah, sorry. That would be -1. There are 3 of those. So you have a 1 in 4 chance of winning. You either lose $1 or you win $2. Okay? So the average of the box is going to be 2 minus 1 minus 1 minus 1, which is -1, divided by 4. So we have -1/4 as the average of the box. What does that tell us? Every play you're expected to lose a quarter. So we multiply that by 100. And in 100 plays, we would expect to lose $25. What a game. Okay. Give or take how much? Well, we need the SE. To find the SE, we have to calculate the SD of the box, which is going to be 2 minus -1 times the square root of 1/4 times 3/4. So 2 minus -1 is actually 3 times the square root of 0.25 times 0.75. So 3 times the square root, 0.25 times 0.75. What does that number tell me? That is the SD of the box. How do I find the SE? Multiply by the square root of the draw, so we times it by 10, and I get 12.9. So, in 100 plays, you would expect to lose $25, give or take $13 or so. You're here. Were you guys both in the counseling office? Okay, I'll fix that. All right. Number 3. At Nevada Roulette, the house special is a bet on the numbers 0, 0, 0, and 1. Oh, 1, 2, and 3. The bet pays 6 to 1, and there are 5 chances in 38 to win. For all other bets at Nevada Roulette tables, the house expects to make about 5 cents out of every dollar on the table. How much does it expect to make per dollar on the house special? So we figured that out. Every bet on the roulette table, the house has a 5.2 cent advantage per dollar. So, in the house special, there are 5 copies of, how much do you get when you win? The bet pays 6-1. So 5 times, if you play 38 times, 5 of those times, you'll be paid $6. But the other 27 times, you'll pay 30. Oh, sorry, you're right. That's way off. So there are 33 copies of, what happens when you lose? -1. Yeah, it's a little bit tricky. Okay, what's the average of the box? Well, 5 times 6 is 30. And then 33 times -1 is -33. So we get 3 out of 38. So 3 divided by 38. Well, yeah, it doesn't matter. Yeah. So what does that tell you about the house special? It's the worst bet on the table. Yeah, if you're the casino, you want people to play the house special. Every other bet out there pays out 5.2 cents per dollar. Yeah, this one you end up paying nearly 8 cents per dollar. So don't play the house special. Bad idea. Okay. B. Someone plays roulette 100 times, betting on the house special each time. Estimate that the chance that this person comes out ahead. So, what is our expected value in 100 draws? $7.8. Right? So the house expects to win $7.8. Okay? For every, well, and we'll just say we're betting $1 100 times. Okay? We want to find the chance. So I draw my normal curve. Here's 7.8. We want to find the chance that the house pays out, or the house gets paid less than 0. So over here is 0. What's the chance of landing in this area? So if you play the house special 100 times, what is the chance you're going to come out ahead? Or at least break even? Okay. Well, what do I need? I need the z-score, which uses the SE. How do I find the SE? Average of the, or SD of the box. So 6 plus 1 times the square root of 5 over 38 times 33 over 38. So 7 times the square root of 5 divided 38 times 33 divided 38. And I end up with 2.36. So 2.36 is the SD of the box. I multiply that by the square root of 100, and I get 23.6. What does that tell me? That's the SE, the standard error. If you make 100 draws, the house is expected to win $7.80, give or take $23.6. So is there a chance you're going to win? Yeah, there is. So let's figure out what the chance is. So how do I find my z-score? What's the distance between 7.8 and 0? So negative 7.8. Divide that by the SE. So negative 7.8 SE. Okay, what does that mean? That's the z-score. How do I find the area? Shade norm. So draw shade norm from that number to negative 0.33. Oh, I didn't clear my draw. But it ends up being 37%, which is probably a lot higher than you thought it would be, right? You probably thought you had very little chance. But casinos they pick games where you do have a chance of winning. So if 100 people played roulette 100 times, 37 of them would come out ahead. And the others would come out behind. So they build the games in such a way that they have a very small advantage, and that gives you intermediate rewards. You're going to win at some point, and a little bit of success gets you into what is it called? The gambler's fallacy. You know, that, oh, I won this time, or I've lost a whole bunch of times, so I expect to win the next time. But they're independent events, and the cards are stacked against you. Okay. 4. A gambler plays roulette 100 times. There are 2 possibilities. Betting 1 on a section each time. Figure 3 on 282. I don't know what a section is. A section bet. Okay, so a section bet is the bottom third, middle third, and top third. Do you see that? So you could either bet 1 through 12, or bet 13 through 24, or bet 25 through 36. Or betting 1 on red each time. A section bet pays 2 to 1, and there are 12 chances and 38 to win. Red pays even money, and there are 18 chances and 38 to win. True and false and explain. The chance of coming out ahead is the same. The chance of winning is $10 bigger, or the chance of losing is $10 bigger.
So wait, are we doing A, B, C, and then you put 1 or 2 for each one?
No, so which one? So you have your choice between 1 or 2. What? Sorry, you have 1 and you have 2. Which one is correct? A, B, or C? Okay, well, we need to figure this out. So the first one, we have a box with 18 ones and 20 negative ones. So the average of the box is negative 0.052. So times 100 draws, you're expected to lose $5.2 per 100 draws. Okay, the SD of the box is going to be 1 plus 1 times the square root of 18 over 38 times 20 over 38. So 2 plus the square root, or sorry, 2 times. 2 times the square root of 18 divided by 38 times 20 divided by 38. So we end up with an SD of 0.998. What do I do with that SD? Multiply it by the square root of 100, so we times it by 10. So the SE is equal to 9.98. So if you play red 100 times, you're expected to lose $5, give or take 10 bucks. Okay, so it's pretty likely in 100 draws you're going to come out ahead. I mean, it's not terribly likely, but it is possible. So if we did it the other way, a section bet. So in a section bet, you bet on 12 numbers. Okay, so you bet either 1 through 12 or 13 through 24, something like that. So there are 12 ways to win, but now when you win, you don't get paid $1. You get paid 2. And if you lose your $1, and how many ways are there to lose? 36. Or sorry, 26. There we go. So we need the average of the box. Well, 24 minus 26 is negative, 24 minus 26 is negative 2. Divide that by 38. Negative 2 divided by 38. So we ended up with exactly the same average of the box. Does that mean we can stop? So my average of the box was, or sorry, right here. Does the SE matter? All the question is asking about is the expected value. The chance of coming out ahead is the same with 1 and 2. The chance, oh, we do need the SE. Sorry, we do need the SE. So the expected values are the same, but the SEs are going to be different because the SD of the boxes are different. Right. So this one we're going to do 2 plus 1 times the square root of 12 over 38 times 26 over 38. So 3 times the square root of 12 divided by 38 times 26 divided by 38 times that by 10, square root of 100, right, and we end up with 13.9. So this number and this number are different. What does that mean? There is more variation in the second game. Yeah, there's a bigger chance error because there's a bigger chance error in 2. So, so A is false, right? So B, the chance of winning more than $10 is bigger with 1. So does A have more variation or less variation? Less variation. Is winning $10 expected or not expected? If you were to play this 100 times, are you likely to win $10 or not? Not. So we want to go with high variation, right? So what is the chance that we win $10? Well, it could happen here, but it's not very likely because we're expected to lose $5 and we add 10, that's only 5. So 68% of the people will be between negative 15 and positive 5, right? Well, down here, we're going to add 13.9. 68% of the people are going to be between negative 19 and, what would that be, 8? So, no, so winning $10, not the house winning. So in the first choice, 68% of the people will be between negative 15 and positive 5, right? Because we took the negative 5 and we added 10 and we subtracted 10. In the second one, 68% of the people are going to be between negative 19 and 8, right? And we want to know who is more likely to hit 10. Well, this is really close to 10, and this is not as close to 10. The chance of winning more than 10. It's not C? I thought the answer was C.
No, the answers are true or false answers. So
Right. So B is false and C is true.
it says B is true.
A is false. A is false.
Because you did them opposite on the board. You did the colors. You did the color first, which is 2. And then you
Oh, I did it. Oh. Sorry. I did them in the wrong order. Okay. So we agree. Yeah, I did them in the reverse order, so sorry. We're on the same page. Yes. Okay. So, yes. False, true, false. Sorry, I did them backwards. False, false, true, false. Oh, losing. It switches from winning to losing. They're not both winning. Yeah. So false, true, true. Wow. That was way harder than it needed to be.